Hello everyone, so today we are going to solve this Leetcode problem, which is the smallest subtree with all the deepest nodes. What this question says that given the root of a binary tree, the depth of each node is the shortest distance to the root. We have to return the smallest subtree so that it contains all the deepest nodes in the original tree. A node is called deepest if it is largest. It's possible in the entire tree. Okay. So let's see with it an example. Suppose we are given a binary tree like this. Okay, so we know that this is level 1, this is level 2, this is level 3, and this is level 4. Okay, so we have to, all the deepest node would be in our last level. Here our last level is 4, so all the deepest nodes are will be in this level. These are the deepest node. And we just don't have to return this deepest node, but we have to return the subtree which contains the deepest node. So what will be that subtree? It would be 9 comma 3 comma 8. Okay, so let's see how we'll approach it. We know how BFS traverse. It traverses level wise. So what we have to do here, that we have to travel level wise and we have to find the last level visited, and we'll store all these nodes in a list. So what we'll do, we'll take a queue and traverse level by level, and then we'll have a parent map which will have the parent nodes, and at last we'll have the list which have the deepest nodes. Okay, then what we'll do, we know that suppose the example would be something like this. This would be our example. In this case, our last level would be this, which is level 3. This being level 2 and this is level 1. Okay. So here, these would be our deepest nodes. And what would be the parent? This would be the parent. But we have to return a subtree. So we have to go to this parent also. In that this case, we'll return this entire tree, which is 3 comma 4 comma 6 comma 8 comma 5 comma 7 comma 1. Okay, okay, so this is known as LCA. What is LCA? It is lowest common ancestor. Okay, now in once we have the list which have all the deepest nodes, then we'll move up and we'll see where all these nodes meet. And where all these nodes meet would be the root node of our final subtree, which we have to return. Okay, now let's see how we'll write this in the code. First, what we'll do, we'll take a edge case that if our root node is empty, we'll just return a null pointer. Okay, now we'll define a unordered map of tree node comma tree node type and name it as parent because it will contain all the parent nodes. Then we'll take a queue which will have all the current node starting from the root node, and we'll push the root node in it, and simultaneously we'll store parent of root as null pointer. Okay, Now we'll define a vector, which is our list, which will have the last level. Okay, we'll name it last level. Okay. Now what we'll do the BFS travel while queue is not empty. Just we have to write the code for the BFS to find the last level nodes in the last level. Okay, so just write the BFS code asap q is equals to size, and then we'll first have our vector to be clear, and we'll have for int of I equal to 0. We'll traverse it till the size, and here what we'll do, we'll see if this node is our last node or not. We'll pop this, and if it is our last node, simply what we'll do last level dot push back of node, and just made the change by updating our parent map, while parent of node left is equals to node, which is our current node, and we'll push this node in our queue, and similarly we'll do with the right node also. If road of right, and what we'll do parent of road of right is equals to node and q dot push node of right. Node of, hmm, 1 second, node of right. What's happening? Mm, Node of right. This is here. Okay. Then what we'll do, we'll just q dot push node of right. Okay. And simply complete our BFS traversal. Sorry for my handwriting. Okay. Then what we'll do, we'll define a unordered set of tree node type. Name it as deepest, which will have the last level dot begin and till last level dot end. Okay, now we'll find the LCA of the last level. While deepest dot size is greater than 1, we'll have unordered set of tree node type for auto node deepest, and we'll insert our parent node in this set. Okay, and simply move ahead our pointer. And at last, we'll have our final pointer in the deepest as beginning. So this was our code for it. If you have any doubts, just put it in the comment section and keep learning, keep going. Bye bye.